Hi, this is a lecture for the percent yield Blendspace. And this is for the lesson, the chemistry lesson on 225, 226, 2021. I'm going to be going through the PowerPoint that's essentially just adapted from the Blendspace, but you can find both the PowerPoint and the Blendspace on the hub. So percent yield is essentially, well, percent yield is how much actual yield you get compared to the theoretical yield. So the actual yield is how much product you actually get out, and the theoretical yield is how much product you would calculate that you would get from your starting amount of reactants. So the theoretical yield is just what we would calculate of product from stoichiometry, but there are going to be experimental reasons why we don't get the 100% full yield. Some of our reactant might not react. There might be all kinds of issues in the reaction itself that causes it to not fully react. Anyway, our equation for percent yield then is just actual yield over theoretical yield, which gives us a fraction between 0 and 1. And then we multiply by 100% to write it in percentage. Okay, so here's an example problem. In this reaction, 2H2 plus O2 yields 2H2O. Hydrogen plus oxygen yields water. A student reacts 40 grams of hydrogen with an excess of oxygen and produces 300 grams of water. Find the percent yield for this reaction. So again, to get the percent yield, we need the actual and the theoretical. The actual amount of water we get is 300 grams actual. So we just need to calculate the theoretical amount of water we would get starting with 40 grams of hydrogen. So essentially we're just going to do mass-mass stoichiometry conversion. We start with our 40 grams of H2. We need to figure out how many moles that is. So we multiply by 1 over the molar mass. H2 has a molar mass of 2 grams per mole, so it's 1 over 2. Units cancel. Grams H2, grams H2. Then we see that, then we multiply by the mole ratio of H2 over H2O over H2. It's just 2 over 2. Moles of H2 cancels. Now we have moles of H2O. We need to get grams of H2O. Grams of H2O, so we need to multiply by the molar mass of H2O. Look that up on a periodic table and it ends up being 18 grams. So units cancel, we multiply out. 40 times 2 times 18 divided by 2 gives us 360 grams H2O. So this is our theoretical. So theoretical is what we would normally get by calculating. Percent yield is just actual, 300 grams, divided by theoretical, 360 grams times 100, and really it should be 100%. We get 83% yield. That's it. Box 4 on the Blendspace includes an additional PowerPoint with some more practice problems. If you need help, go to the Blendspace for that. I'm going to work through one example fully. For the reaction represented by the equation chlorine, Cl2 plus 2 KBr yields 2 KCl plus Br2. So chlorine plus potassium bromide gives potassium chloride plus bromine. Okay, so calculate the percentage yield if 200 grams of chlorine react with excess potassium bromide to produce 410 grams of bromine. Okay, so this is our this is our reactant, 200 grams of chlorine. So I'm just going to write that, 200 grams. And it produces 410 grams of bromine. So this is going to be our actual yield. If we want to get the percent yield, we're just going to need the theoretical yield. So to calculate that, we just want to find the theoretical mass of bromine, Br2, that's produced as a product. So let's do that just using stoichiometry. Start with our given 200 grams of Cl2 is our starting reactant. We need to convert to moles, so I need to look up the molar mass of chlorine. Chlorine has a molar mass of 35.45. So the molar mass of Cl2 is 35.45 times 2, 70.9. I multiply by 1 over that molar mass, so it would be 70.9 on the bottom grams of Cl2. And at the top per mole is mole of Cl2. Grams cancel. Grams Cl2 cancels. Now we'll multiply by the mole ratio of bromine to chlorine. Well, it's just 1. We get 1 mole of bromine per 1 mole of chlorine. Again, moles of Cl2 cancel. Now we have moles of bromine. We need to convert that moles of bromine to the mass of bromine. So we multiply by the molar mass of Br2, bromine gas. Bromine has a mass of 79.904, so Br2 has a mass of twice that. Atomic mass, that is. So we multiply by the molar mass, it's 159.808 grams of grams of bromine 2 per mole of bromine. And we got that 159 from the periodic table. It's just the atomic mass of bromine times 2. We're left with moles of bromine. All we need to do is now calculate out our mass of bromine. So 200 times 1 times 1 times 159.808 divided by 70.9 divided by 1 divided by 1. We get 450. To 3 6 figs, it's going to be 451 grams of Br2. So this is our theoretical yield. And our percent yield then is our actual over theoretical times 100%. So let's just plug it in. Our actual yield was 410 grams. Our theoretical yield was 451 grams. And we multiply by 100%. Plug that into a calculator. We get 90.9%. 90.9% yield. That's it. I guess it would be 91%. The difference in my answer and the multiple choice answer is probably some of the rounding that must have been done. Box 7 on the Blendspace is extra help if you want to see more examples or need extra practice. Go to the Blendspace for that. Box 8, 9, and 10 are group practice problems that you can work in the breakout teams, the private channels that you have access to on our team. Let's see. So here is one of our practice problems. Here's our second practice problem. Both are percent yield. Box 11 is just a refresher on how to calculate theoretical yield. Essentially, it's mass to mass stoichiometry. So the mass of our reactant would be mass A, and the theoretical mass of our product would be mass B. Your independent practice is to complete the percent yield assignment on Quest. That is going to be due at the end of your normal class time. Actually, no, I believe it's due at 11:59 on Friday. Bye.